This podcast is supported by Hannover Messe, your meeting place for the industrial community.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and it's a pleasure to talk to
Peter Sieberg. Good morning, Robert. Hello, good morning, good evening, good afternoon to our listeners, wherever you are in this world, on this planet.
Peter. A warm welcome. Welcome back to our podcast. How was your trip to Thailand?
I was going to leave it open. I said somewhere because I was spending time considering between the Tropic of Capricorn and the Tropic of Cancer. I'll come to that in a moment, where the sun shines most of the day. It rains every now and then. Water temperature equal to air temperature. Well, I can tell a little couple of more things. What does really, and I somehow, as I always do, came to make a relation to the things that we do. When I was making these pictures, when we got up in the morning and the sun was rising, I was realizing that the sun is rising already this time of year, almost straight into the air, right? So that's a big difference to where we live. We live here in Europe at, not sure what is it, something like 40, 45 degrees or something like that, I believe, right? And there almost it's like the sun is rising straight into the air. If you get a feeling for that, if you get an eye for it, you can see that. And interestingly, and that's why I'm saying it, it always has interested me so much to get a feeling for the relationship between Earth and the moon and the sun. And it's always like, I always get so excited about it.
That sounds a little bit that you smoke something there.
Oh, that happens there as well. But I was told that you're right. I mean, that's not, no, you're not right. I'm not. Very clear. Doesn't matter. I'm not going to make a pro or contra, but I'm going to share that. You see many shops there. You many times smell, yes, but I was told that you need to be so awfully careful. So I don't, because, you're going to be put in jail just like that immediately, right? So other topic, the point I was going to make is that I always get so excited about, and I always am looking forward to keep a model in my hand. And when I want to understand better why, the sun goes up differently in that part of the world, I always take, and when you are kind of on the beach, you always find somewhere a balloon or a ball, right? And then you look
balloon?
at it. Yeah, no, that's the small ones, right? A ball, children are playing with at the beach. And then you change its axis, and then you look at it, and then you start turning it, and then you can see why the sun goes up differently, in our part of the world from that part of the world. So long story short, it is about, trying to get a better feeling for, and in this case, there's a huge interest and the similarity with what we are doing all the time. It's always trying to look into the future with help of AI. That's I really believe is what we do, right? Again, today.
You're a philosopher. It's philosophy with Peter.
Maybe I am, yeah, right? Well, sometimes, but in the end, that's what I believe that it is what we're trying to do with AI. Now, AI is helping us to look into the future. It's trying to predict. And and that's whenever we talk about models, this is a model, and I looked. You can buy a model at Amazon, I guess, anywhere else for something like 30, 40 euros, dollars. It's a very small thing. It's for children, but I like to be a child every now and then or all the time. Or there's a more expensive one as well. I don't want to put, which is about iron, aluminium, messing, whatever it's called. And it's a very expensive one. I didn't buy any of those two ones, but I was really very close to doing that and having a model like that. And whatever we're going to talk about today, ChatGPT, I guess, and other things, it's always about predicting what is the sun, what is the moon, what are the stars doing. And we're predicting, what are words doing, basically, or what are sensors doing, and why are they not showing us what it is that we would like to see?
Peter, I missed you a bit. I missed this discussion. I missed this philosophy by Peter Sieberg. And of course, our listeners also missed that. Let's start with the news part, Peter.
Good. Should I start?
Oh, I can start also.
Whatever.
I already mentioned the discussion on open source and AI in the last weeks. And Thomas Domke, he is the CEO of GitHub, wrote a very, very interesting article about open source and the AI Act. And his suggestion is to exempt open source developers from the regulation. And I think that's a good idea to improve innovation on this topic on open source and the guys. And I will put the whole article into the show notes because it's very interesting to read his ideas and to exempt open source developers from the AI Act. That's very, very interesting. And it all depends on open source. I think the race on AI, we only can take part in this race if we focusing more on open source in every industry we are dealing with.
Why would we do that? Why would politicians do that? Why would he think that politicians, I mean, in the end, the people that we elected, right? Why would they be open for exempting the open source community? Which at the same time, if I understand correctly, what you mentioned last time, a week or two ago, and I've read something about that as well. There was almost like a direction saying, this is the end of open source because of what is happening with ChatGPT, I believe. How does that fit together? Not sure I understand that.
Yeah, that's a huge discussion in the AI community, I think, in the US about the future of open source. And the window of opportunity to use open source, I think, is closing a little bit in USA. But that's a big chance, I think, for Europe to focus on open source and to go on open source, because the advantage of the American companies and what they have, we can't do that alone. It's not possible for BMW or SAP or I don't know, or Audi or Siemens. The future is to work in open source. And if the USA is going out and leaving this open source philosophy, some big companies, I think that's a big chance for Germany or for Europe to stay in there and to give open source developers more opportunities to work on that. And yes, it's the CEO of GitHub for sure. He wants to push open source. But I think the discussion, a lot of people do not realize this discussion, what's happening in the USA with open source and Google and Microsoft and Meta and DeepMind. We have this fantastic interview in Time. I think nobody read that in Germany, this interview with the CEO of DeepMind, who said, we are coming to an end of open source with AI. And that's dangerous for Europe.
Well, what I recall is that he was Demis, right? He was saying, he was giving a negative example of, and I strongly agree with him, where, the OpenAI guys have, put something onto the market, which, he, I believe, is saying so much as this was irresponsible, what they are doing, because now they let something out of the cage. And we come to that in a moment. And we say, why didn't Google do that? That's the first thing I'm going to talk about. Well, because I'm not going to choose party left or right. That's not the point. But they, eventing the base, this technology kind of, or the extension of the base technology, the transformers, they kept it. They did loads of stuff with it for 6 years. Comes a company which didn't put a lot of effort into the base technology. They threw it onto the market, where in the past it was, 1 in 10 or 100,000 professionals like you and I, and the people really working with the technology. Now it's the complete world. It's 500 million people suddenly exposed to a technology that Demis said, I believe, and I strongly support, wasn't ready to be put onto the market.
Exactly. And it's an ethic discussion. It's a discussion about money. It's a discussion about ethics. And it's a discussion about politics. Yeah, it's very interesting because I think the open source community always acts as the grassroots of technology. You know what I mean?
Yeah, sure.
Yeah. And every day there are ideas and shared ideas and possibilities. And I think it's a good idea to discuss this topic, AI Act and open source. Yeah, I think we need to have this discussion.
Yeah. And there's nothing wrong with the open source community continuing to develop whatever they think is that we, the world, should be developing, right? I mean, and if the EU Commission with their AI Act, and we're going to be hearing about it, some point in time again, I'm sure, and there's going to be certain whatever regulation in place. at that point, of course, let's assume that 100 pieces of software development come out of the open source community, and maybe for whatever reason, only 10 or only 50, only 90, I don't care what number it is, are going to go through the regulation, and the other 10 from the beginning not. That's a different thing, I believe. Now, of course, if those people then understand the regulation at some point in time, and they know that they will be held responsible for the regulation as well, for me, it's impossible to imagine that they will not be held accountable, then of course the interest to be developing something which they know is not going to find a market, at least not in Europe. And by the way, not in Europe, because Europe working very closely together with the United States, many, many other countries to synchronize this AI Act. Right?
You want to add something on this topic because you mentioned ChatGPT. I think you have also news of ChatGPT.
Yeah, I have two pieces today, and both are somehow related. So my number one is the 100 billion Google mother company Alphabet stock loss in one day. That was a week. That's February 5th ago. And it was about them introducing their ChatGPT rival called BART. We hadn't heard about it. I hadn't heard about it yet, although I'm certain that they had been working on it for a longer time. Now, investors withdrew. They sold, so they did not burn as many times as being, kind of incorrectly, I believe, communicated. But they sold and it went down the day later, February 6th, a total of 170 billion US dollar decline. Now, to put this into perspective, and I should open up that I believe, still own one Google share. Yes, I did have a number until I believe a year ago. I don't have any stock, with the exception of this single one. So from that perspective, I still have my feeling, my different viewpoints that I'm representing. I want to put this into perspective where I believe this is happening and what we, from an industrial AI perspective, what you as a listener can maybe learn from it. And I want to go back to the 1990s. I was sitting in a car with Dave House. And we were moving, where did we move to? Was it the Hannover Messe, I believe? Hannover Messe, our current sponsor. And I believe that Intel at the time had a very good quarter. And the stock at that day was down 1 percentage point. So I had the option at this Dave House. He was the next in line CEO at that time from Intel. And there was, Dave, if you're listening, hello, how are you doing? And you told me at that time that the stock is always about, and here we go again, it's about trying to predict the future. It's expectation, and then I understood. I said, Dave, how can it be? We had such a big quarter. And he said, well, the expectation, Peter, was whatever, 10%, and we only did 9%. And that's why the stock came down 1%, right? Now, why did Google come down? I do want to try to share my perspective. Why did the Google stock come down? While Microsoft, as the OpenAI big investor, they plan to incorporate ChatGPT, we can chat about that, into the big search engine. They came up almost like 5%. Now, we don't even know today, is my understanding, the real capabilities of BART in detail. Was it really this one incorrect answer to a question? There was a question, and there was an ad on Twitter, I believe, that was shared. It said, what new discoveries from the James Webb Space Telescope can I tell my 9-year-old about? And there was a response that said something about the telescope, that the very first pictures of the exoplanets, planets outside Earth's solar system, was the James Webb Telescope. Now, that is wrong information. So it's not that it was telling complete crap, but it was wrong because... And very, very soon people found out now it was the the Southern Observatory's very large telescope that actually took those first pictures of those special celestial bodies in 2004. That was. Oh, interesting. I didn't realize it was. This is now about our global Earth system as well. Now, I believe what it has all to do with is Clayton Christensen. We talked about him. He passed away 2 years ago. He wrote the book, Innovator's Dilemma. And the title says it all. Innovator's Dilemma, when new technologies cause great firms to fail. That's the title. And it's all in there. There's another one from Andy Grove at the time, the 1990s, Intel CEO. And he shared this with his employees, right, in very, very much detail. Now, so this time it's about Google.
So it was your Bible, right?
Well, there's a second one I come to in the end, because Andy wrote another one together with Christensen, believe, or just by himself. But Andy was very, very strong on this idea, right? He pushed it in us. So that every sales conference when we came together, strategic marketing, he did that, yeah. So Google owning 90% of the search market, they are the incumbent. They have to defend. They need to be very careful. They cannot introduce new technology. And that's the second thing I want to talk about today a little bit. Transformers. Attention is all you need. They introduced this technology from their research, right? In 2017. And at the same time, this happened to Microsoft with search. Amazon Search was introduced also in 1998, the same year that Google introduced their search, right? So we'll see what's going to happen in this, because this is all about search now. And I'm gonna finish off and suggest what I believe you listeners can take away from this one. But they will both continue to develop their technologies, build them into search and other products, providing more or less ? I'm a big fan of Gary Marcus, and he's almost like bashing on a daily basis. But I do follow what he's saying, right? So my personal, let's say, message to you as industrial AI listeners, if you do not know, if you haven't heard about the Clayton Christensen's Innovator's Dilemma, when new technologies cause great firms to fail, I would suggest go and spend an hour to read it or read an extraction, because AI, which is what we talk about here, industrial AI, as the new technology, will help you to do so. If you're a startup, if you're a small company, then you can do exactly the same thing. Now, in this case, we're talking to big companies. And if you are a big company, then you better should also know what it is that can happen. And the second book that I want to share, and maybe you want to look at, that was the one from Andy Grove. And again, the title says it all. Only the paranoid survive. Do you need to be paranoid? And he talks about so-called strategic inflection points. And he was putting those in our brains, so to say, at my Intel time. They are moments at a company's existence and what is involved in directing a leading company. So that's what I want to share with you. What can we learn from this, what is happening now here around search? And how could this happen to you, listener, if you're part of a big company and you own a big market share, or if you're a listener from a startup and you might be able to do the same to a big company.
And I want to add something, because I sent you this morning this nice cartoon. You have seen that with Homer Simpson?
Yeah, I did. I've been looking at it a couple of times. I'm not sure I understood it completely.
In the past, when you scroll through LinkedIn, there were these guys called metaverse experts. Yeah, and I think that was a trend 2 years. Metaverse expert, and now these guys are changing into AI experts because they're chatting about and writing about ChatGPT and stuff like that.
Right.
So be careful about the AI experts on LinkedIn, I think. 2 years ago, they were metaverse experts. Now they are AI experts. We will see what comes tomorrow. But I think that was a very nice cartoon. Maybe I can put it in the catcher, this cartoon, because it is very funny. And when I saw that, I said, yeah, that's right. Be careful about the new AI experts on ChatGPT.
Because the Microsoft, they had an industrial metaverse, and that was
it's closed.
Did you see that? Oh, yeah.
It's closed.
Same topic.
Yeah.
For whatever reason, I'm not sure. Yeah, I never really, I don't know. What was the thing called that we did 10 years ago? We went into the internet and we were trying to walk around as a digital person. What was that called?
This game, yeah. Second Life.
There you go. Well,
yeah.
If I may, I do want to quickly talk about these transformers. I'm not going to go into much detail, but I do want to, because I have been running into it myself all the time and since a long time. So very quickly about the technology behind ChatGPT, behind BART, behind the LLMs, behind the large language models. So I want to give, and then I'm going to we are going to put some references, some URLs in the notes, and you can read about it yourself if you want to. So very important, these transformers, they were introduced by a team of Google employees. Coming back to the thing that we just talked about, they kind of invented it. They didn't invent, I believe, but exclusively concentrating, as we will hear, on transformers is what they introduced. Attention is all you need. That's the quote unquote, right? And then comes OpenAI. And I think our friend from Meta, or is it then with Facebook? What is it? The French guy?
Yann LeCun.
Jan, yeah, right. And Jan had a wonderful overview with, the amount of research spent into, I believe, directly related to transformers. And number one is Google. Somewhere there's Meta, there's Amazon, there's and OpenAI is there at the very bottom. And I think he was kind of suggesting that maybe companies that have put all this research into the technology, like Google, they were not sleeping, I believe, maybe, but that's the problem that we discussed before. I'm not going to go into the details here. But what is important is here, and that was on a conference, on the NIPS conference 2017, a couple of names. I'm not going to explicitly call them out. They're with one exception, Aidan Gomez from the University of Toronto. They are Google guys. Yeah, I must say guys, as far as I understand their names here. So what they say is that the dominant, that's the first line, sequence reduction models are based on complex recurrent or CNNs, convolutional neural networks, right? And then they say the best performing models also connect encoder decoder through attention mechanism. The attention mechanism was there before, right? And what they do, this is then all quote unquote, we propose a new simple network architecture, transformer, which is based solely on attention mechanisms. And then they look at translation as one typical thing, right? English to German, French, and they say it's superior in quality. It's more parallelizable. That's what is very important in the end. That's what they had been looking at. So they say self-attention has been successful in the past already. Now, and they specifically, and that is important so that we can put it into perspective, they specifically refer to Sepp Hochreiter's and Jürgen Schmidhuber's long short-term memory, 25 years this year. And they start with, this paper says, recurrent neural networks, long short-term memory, and gated recurrent neural networks, they have been firmly established as state-of-the-art in sequence modeling. And then basically what they talk about is that there is the thing that these cannot do, basically, they do not paralyze now. And they say they're going to introduce this parallelization, which in the end is going to, give them this capability for a lot of less training, basically. So the transformer allowing for significantly more parallelization. I'm going to stop here. If this is something that you say, okay, I do not want to understand the next step, because, we have been hearing now for how long, a month or two, or this is going to go on, and there's going to be additional development, also technology development, but this is the base technology behind the large language models, ChatGPT, BART, and all the other ones that we have not heard about. Is not only ChatGPT. And if you want to know more about it, then, go for it. We'll share the link to the paper.
And you mentioned Yann LeCun, and I found his quote on this topic you mentioned: data on the intellectual contribution to AI from various research organizations. Some of organizations publish knowledge and open source code for the entire world to use. Others just consume it. And that was a hint to OpenAI.
So we're back to the topic that we had before.
Yeah.
It means that companies like, and I recall, I think Google is number one there, of course, and I believe Microsoft maybe is there as well, Amazon, and of course, Meta is there as well. Now, does that mean at some point in time they're going to say, okay, we're going to stop doing this? Look at this. We put 1 billion or whatever. 1 billion? What is 1 billion these days? We put did they put 100 billion? No, I don't think so. But they put loads of money, and then on one day they lose 100 billion, the 100-fold of the 1 billion, because another company used their technology, which they could only do because it was open sourced.
Yeah, you mentioned LSTM because now we switch into the main part, and there LSTM plays also a very big role in the ABB project we are talking about. I have 3 guests from ABB. It was very interesting. You organized this episode. I recorded this episode, and it was a pleasure to talk to these 3 guys. And first of all, we talk about the use case, and then we talk about the technique behind the LSTM algorithms and how they use this algorithm. I think it's a very interesting episode. Peter, it was a pleasure to talk to you. A warm welcome. Welcome back to our podcast, and enjoy listening the main part.
Welcome. Nice to be back. Thank you, Robert. It is good to be back north of the tropics again.
Thank you.
Thanks, brother. Bye-bye.
Today, we have 3 guests from ABB. John Pretloff. Hi, John.
Good morning.
You are calling from Oslo, right?
Correct.
And we have Azam Kotiwala and Benedikt Schmidt. You are both based in Germany.
That's right.
Yes, exactly.
Good morning, Benedikt. To avoid confusion, we are splitting the episode into a business part and a tech part. And Benedikt will be our red line during the whole episode because he's all in the business part and in the technical part. But before we start with these 2 parts, please introduce yourself briefly to the listeners. And John, you start.
Hi, good morning. My name is John Pretloff. I am a Global Technology Manager in ABB for our energy industries business. And part of my portfolio, the interesting part of my portfolio, is looking at technologies supporting our customers in their vision of moving things more and more towards autonomous operations. I work very closely with customers and use a good deal of my time to understand exactly what it is that they need now and in the future. And I feed this back into our development teams.
Azam?
Yeah, thanks. My name is Arzam Kochiwala, and over 5 years now, I've been working as a data scientist at ABB Corporate Research. Here, we do applied research in industrial AI for our core business areas. These include electrification, robotics, motion, and process automation.
And last but not least, Benedikt.
Thanks a lot. My name is Benedikt Schmidt. I'm product owner for advanced analytics and machine learning on the control platform at ABB. A role that I started quite recently. So till end of last year, I was like Azam working at ABB Corporate Research, and they are always been working with industrial data analytics. And now in the product owner role, the idea is also to bring some of these topics closer to the business.
And today we are going to talk about your Augmented Operator. Honestly, when I first heard about your solution, I thought, what a great idea and what a AI super innovative solution. John, we wanted to talk about your solution. What is and what did you think when you first heard about the project?
I thought it was spot on the requests that were coming from our customers and our partners. And they have many of them have very, very complex process facilities. They are producing huge volumes of product every year. And these over time are becoming more and more complex. And you will always have a human operator in charge of that process. As these plants produce more and more product, any tiny mistake or error on behalf of the system or of the operator themselves can incur both risks to safety of the facility and of the people around about, but also can have quite an economic impact. So any kind of assistance and any kind of system that we can help identify anomalies early on that can be dealt with, that we have the time to make the correct adjustments, is of very significant benefit to our customers.
So the Augmented Operator supports the human, right?
Correct.
What is the aim of the Augmented Operator, Benedikt?
The aim of Augmented Operator actually is really to bring the plant operator with his ongoing need to have a good situational understanding of the process and of the condition of, in the best case, the whole plant really into the center of attention, and to bring data-based support mechanisms, assistance systems to the operator throughout this job. And one could also say a little bit, there have been all these digitalization efforts in plants throughout all these past years. And now there is really this quite strong communication backbone, the strong way of collecting data from the process, that a point has been reached where it's really possible to not just have monitoring capabilities, but also really to provide a variety of assistance features, and maybe in the future also with that step by step going closer to autonomous. But for now, it's really having the operator in the center of attention, like in a car where you also have your assistance systems and the drivers in the center of attention.
What I think is very interesting, because you explained our briefing call that it's not also about where is the problem, but also why there is a problem and what you can do. I think that's a new quality for operator service you provide, right?
Yeah, absolutely right. I mean, before this sort of function was tested and put into use, typically the operator in a facility would only have alarms. So if a process parameter was going close to an alarm limit, an alarm would go off and the operator was then expected to react. It would then try and identify what's the cause of that alarm, what can I do to try and bring things back to stability. What we're able to demonstrate and what we're offering now with these AI-equipped tools is to get a much earlier warning that something is drifting off specification. That gives the system time to analyze the signals, have a look and see if something really is moving off spec, and to also suggest what might be a useful course of action.
Yeah, that's the most important point. Yeah,
it is. So the system will then, you have the ability to see it early, which buys you time, which is very important. But you also have the ability to use this AI tool, if you like, as a buddy. So it will say, I think this is what's happening. I've seen something before. I think this might be what is going wrong, or it will give you one or two options of how you might then react to that. And I think when we get into the technical part, you'll hear how you can present to the operator 2 or 3 alternative ways of recovery, and the operator can then have a look at them, can maybe make a decision, or can even run it through what we call a what-if analyzer to look at what is the consequence of making that choice before actually implementing it. So it really is like having a buddy on board who you can spar with and explore these different choices.
For this, Benedict, you need an explainability of the AI solution, or is there no explainability?
There is some degree of explainability when it comes to, as John said, this informing early enough and buying you time. So showing the reasons why the system thinks something is going off the lane. That's one aspect. And the other thing is, and for us, it really was important to really bridge in the thinking and the workflow of the operator. And that's a person who thinks in terms of the plant topology. So whatever we recommend and whatever we show is closely aligned with the typical way how information is presented to the operator, which always is relating information to the plant topology and to the process and process state.
And my question is, you tested this solution on the oil platform, right? And how adaptable is the solution for, a food manufacturer or a machine building company, or is it focused on the energy sector, John?
I think this first work, and certainly the work that I've been involved with, because that's that's where I sit in the organization, has been on energy industries. But I don't see any reason why it wouldn't be equally applicable to essentially any production system.
The idea to invent this operator, was it a customer demand, or was it an idea by ABB? Or the customer said, we need something for our operators, John?
Yeah, in this specific case of using this test data, I think it was probably a little bit of both. We're very fortunate in ABB. We still have a corporate research organization. They do fantastic work, as we said in the introduction. They're very applied. So they look very clearly at solving real world problems. So as I said in my introduction, part of my job is to listen to the customer and listen to what they're saying and in which direction they're going. Sometimes they articulate that very clearly. Other times, I have to try and draw the picture in between what they're saying and what that might mean. So it would be difficult to say in any particular case whether it was clearly a customer pull or an ABB push. it's very often a little bit of both. And then we can put together the pull and the push, and we get good results and good success.
Can you add how adaptable the solution is to other industries?
So actually, we also had a second test case with a customer with production in the process industry. And there we have seen that the rationale behind the tool and the different steps of this, one could say, augmented operator workflow, that they at least seem to be generic enough that they cover different fields.
You mentioned this workflow. Can you explain us this workflow?
Yeah, so basically it tries to go through the steps that also a human has in mind when we encounter a problem. So I mean, first thing that we would do is we realize something, we spot something, and that's actually what's also happening here. So there is an anomaly detection in place, which monitors the different sensor outputs of the plant and spots deviations from the normal operation in the specific plant state. So we know what state the plant is in, and if we deviate from that based on the sensor outputs, then the system informs. And based on the location in the plant, this can be 10 or 30 minutes before an actual alarm would happen. And then the next thing that a human would do is thinking about, okay, what actually is this? Because we see the symptom, but we don't see the root cause. And there we have something we call smart alarm list or topology-based root cause analysis, where we show the symptom and we also show pieces of the topology of the plant and what's going on what has recently been going on in these segments of the plant. And like this, the operator can backtrack to the symptom. And then two closely connected things come into play. On the one hand, funny enough, the plant is full of expert knowledge in the historian. So continuously, the system tracks what operators are doing in certain situations.
That's interesting. The system is learning from the operators.
Exactly. It looks into this plant historian, which sometimes for 10 years has collected information. The plant is in this state and the operators are doing this or that thing. And we do something which could be compared a little bit with workflow mining, but there's a variety of things involved here. But the idea is that we come up with pairs of situation and reactions to situations. We can propose this to the operator. And as John mentioned earlier, then there is the what-if capability. We have machine learning models in place which allow to test what happens if I now go with this workflow. And then they give a certain degree of indication what's exactly happening. And the last piece of the whole thing, that's a little bit, one might could say a little bit like Google for plants. That's a search engine on top of all the process variables and on top of all the engineering documents and operator notes and so on, which also helps to understand, has this happened before? Are there any further earlier good examples of this situation and what people have done in these situations? And in combination, these things are supposed to really help people to, I talked a lot, but to quickly come up with a solution to how to address the situation.
Perfect. I have one more question, Benedikt. You mentioned the oil platform and then process industry, and everybody knows how the IT infrastructure, communication infrastructure is in a brown field. Where does the solution come in and where are the interfaces to other systems from the augmented operator to, an MES system or what else?
So in the most basic form, what's required, that is definitely access to historic data and to live data. And if these two are given, so process variables and event and alarm data, then many aspects of this can already be realized, plus topology data. So with these pairs, you already can have a good start. At the same time, for things like the what if, you would need a high fidelity simulator. And in general, what we realized is, already these days, operators get more and more tools on top of their work. And we are quite convinced that only if we get very, very close to their actual operation environment, to the control system. So it's really embedded in the control system and the operator screens that they are used to work with, that only then this can be successful, because it shouldn't block their typical workflow, but it should seamlessly integrate.
This control software, is it also provided by ABB, or there are different other companies who offer this? And is it easy to add on your operator?
Yeah, for sure. ABB has this type of software, and that's one of the things that we are currently looking into and working on, this type of deeper integration of this type of tool into the existing operator offering.
Okay, Azam, let's jump into the technology part. When we go in our archive of our podcast, we will find a lot of combination of good old-fashioned AI and modern approaches. And you have chosen a deep learning approach. Why?
Right. I think that excellent question, a question that we often are asked within the organization and are also asking ourselves when we are doing research. I think the augmented operator solution, as Benedict just explained in lots of words, right? It has a workflow of 5 different pieces. So it wouldn't be right to say that we've used deep learning in all of the augmented operator workflow, right? So deep learning has its place. There are specific use cases where deep learning fits very well, and we have used it. But in other parts of the solution, we have not used deep learning, and I would even argue that it's not needed. In fact, to answer your question, I would like to mention that when we are doing in the applied research in industrial AI, of course, we are very close to the research community and looking at what are the new developments. But I've become more and more convinced over the years working on industrial AI that for the most part, the state-of-the-art technology that is already there now can solve most of the problems. Many times, the industrial space is complex, but the solution to some of the problems that we have in industrial AI are not necessarily complex. So what I'm trying to say is that the state-of-the-art technology is there, but rather most of the times we need to find clever ways of applying those methods, and that includes more often than not including the domain expert, domain knowledge, getting not only more measurement data, but, trying to understand what exactly happened, try to provide more context and metadata to the data. So it's not always deep learning, is what I'm trying to say.
Okay, that's good. Let's come back to the deep learning, because you're using the LSTM algorithm.
Right.
And we are happy because we have a lot of episodes with Sepp Hochreiter, and most people connect LSTM to Siri or Alexa or stuff like that. And what can it do on your approach, and how does it work in your application, these LSTM?
Actually, that is a very good example and analogy to what we do, the translation models that you mentioned, or language models. The thing that is common in between those types of models and the models that we have used is that in both cases, the data that we're working with are essentially sequences. Right? And LSTMs, recurrent neural networks, transformer models, and so on, they are very good at handling sequences, right? So in our particular case, now let's talk about deep learning, right? So for instance, in the what if tool that we have, that Benedict also just mentioned, can also leverage a high fidelity simulator, as well as use or leverage operator actions from historical plant data. There we collect a lot of these cause and effect, right? So like if the operator, for instance, in the historian we see has done something in the plant, for example, change a valve setting, for example, and then we can observe what happens downstream to certain flows. And then we could also do the same thing in using a simulator. So we have a lot of data where something has changed in the plant, and then something as a result of that can be observed, right? So we're talking about a lot of pairs of sequences. And when we prepare the data in this format and want to learn a model, then deep learning models, in particular LSTM models, are a very good fit.
Mm-hmm. And these are time series data, right?
That's correct.
Yeah. And you mentioned a lot of process data. And how difficult is it to use this process data since you have different parameters on this process data? Or are there no difference between these process data?
Yeah, I think to answer that, we can take a little bit of a step back. So coming back to what Benedict was just mentioning with respect to the different data sources that we work with, right? So essentially, I would say in the context of the augmented operator and in general in industrial AI, more often than not, we are working with time series data, right? So measurement data from different signals, the sensors, and so on. So on one hand, we have this measurement data, which is the plant historian of the various sensors and so on. At the same time, another key data source is the alarm and event data and the audit trails, right? Like the documentation of what the operator has been doing. So at the end of the day, as I was mentioning, it's not only getting more and more of this measurement data that helps us, but it's rather the combination, because we need to contextualize this measurement data. And that's where this process data and the alarm and events, the audit trails, as well as, interviewing the operators, doing site visits, trying to provide more context, it really helps. Yeah, to enrich and to contextualize. For instance, it may have been the case, Benedict mentioned 10 years of data, right? But in our experience, it's not as simple as getting 10 years of data and simply, passing it to the algorithm and done, but rather we have to understand either in the first data-driven way and then validate with the experts, with the people at the plant. Okay, 2 years ago, was there a change in the plant? Was there some equipment that was replaced and things like that?
You mentioned your solution was able to cope with the requirements of real industrial environments. How you make an algorithm or solution industrial grade? What does it mean? What were the requirements on this oil platform?
There's one core element, and whatever we do with this type of solution, on the one hand, never should interfere with the ongoing control, operation and safety of the plant. So never touch that. And the second part, obviously, whenever you provide a recommendation, only provide recommendations which, and you already mentioned explainable, which allow a human to cross-check this recommendation. And if it's severe things, like we also talked about this workflow-based approach, in certain cases it's also required to have pre-checks of the data that the system is allowed to propose to the operators. So a kind of a governance structure. For sure, if you do this in a piloting phase, then anyway, all the people consider it with a grain of salt, so to speak, and don't use it as the actual support system, but it's more running next to them, and you do case-specific analytics. But these are definitely requirements when you get closer to a product there. And another thing, just to briefly mention, I think engineering is always a big challenge here. And engineering in plants can be an extremely time-consuming and tedious task. And at least what we try with Augmented Operator, that is to keep the engineering effort low by reusing whatever is digital there in the form of topology information and the historic data.
Artem, you want to add something?
Yes, Robert, thanks a lot. So actually, I would like to add 2 points to what Benedict mentioned. So firstly, he mentioned that in the context of explanations, right, for the human. So I would just like to add that we also did a study understanding the various different users that are there in the industrial context, right? So when it comes to explanations, firstly, they have to be in the domain language of the one you're explaining to, right? And even in the industrial context, we might or we likely need different explanations for different users, right? So the control room operator, for example, is often under a high time pressure and the stakes are very high and they need to make a decision very fast. So if you, for the sake of example, are going to give a 1-paragraph explanation, it's probably not going to cut it. Whereas, for instance, someone who's a process engineer who may have some more time in retrospect looking at the same situation that has happened in the past could be given the different explanation, right? So to answer your question, what makes it industry grade, right? So, these are the types of considerations that are very, very important. And the other point I wanted to highlight is that your question can also be, I would say, rephrased in another way to say, can we take certain AI technology off the shelf and simply apply it, the process industry, for example. And what we found is that more often than not, that's not the case, right? Some adjustments are needed. But what's also very interesting is that in applied research, what we do is that we sometimes look for technologies that are very successful in a different domain. But then we find that they could also be, when adjusted a little bit, become very valuable for industrial AI applications. And an example of that is process mining technologies, right? So we just mentioned having audit trails and event logs. And when you have a stream of events, then something like process mining, which is very successful in other domains like, for instance, banking and business, which we found in our case in the workflow mining that we have in the augmented operator to work very well, actually.
Right. Do you need to adapt the LSTM? Not really, right?
The LSTM requires hyperparameter tuning for sure. You cannot skip that, I would say, especially when you want to improve the quality of the models, especially when we have data coming in from the historian as well as the simulator, right? So from, let's say, different sources, and you want to make sure that it's tuned. But one learning there I would like to share is that we found out during the context of the augmented operator as well as other projects, the most important thing is not the hyperparameter tuning, but rather the quality of the data, right? So as mentioned before, it's not only required to have data in more quantity, which is also required, but what's more important is that the data, if it had, let's say, if there was missing data, it is filled in correctly and it represents the reality given the correct context and so on.
We are talking about a highly individual model for one, in this case, oil platform. And in the moment, I think there's a trend to share models, to promote models, to have models that run very fast on different applications. Why you choose this way to have highly individual models, Azam?
I think in our conversation so far, it does seem that the models are, let's say, highly engineered and individual. Whilst that is true to a certain extent, I would say that taking a little bit of a step back, actually where the models are coming from are generic pipelines, right? So we make use of automated machine learning wherever possible as well, right? So a lot of the hyperparameter tuning and so on, this is taken care of, right, in an automated fashion. So I would say that a lot of this is generic. However, working with different data sets in the industry, I think there is benefit in doing things like transfer learning. And let's say you mentioned Greenfield a bit earlier. We can use models from various different brownfield installations for Greenfield. But as we already mentioned, that our augmented operator then also learns as we go, right? And that is very, very crucial. I don't think that it is sufficient to just use a model from a different side, on the different side, and let it be that way. That's a starting point, but then it needs to be adapted over time.
I read your white paper on this topic, and there's one sentence. The customer can operate the deep learning models himself. Whoa. Why and how? Why he needs to do that?
Right. So coming back to the what if simulator, right? One of the things that we found whilst doing the project was that whenever we talked to our experts, right, the engineers who've, let's say, worked on the platform or the experts on the customer side, what we realized was that the technology to provide this functionality we have tested and we have provided. But another question that comes or is really important is that what are the useful and meaningful use cases for this technology within the entire plant, right? So you have a big plant and not every plant section is going to be the same and so on. So what we envisioned and did a proof of concept on is to develop a tool where we first enable the experts themselves to, for instance, analyze these previous cases of operator actions, right? So what did the operator do in the past, and or the data that we have generated from the simulator across the different plant sections, and select a specific plant section. So once they've actually engaged with the data themselves and are able to then say, you know what, in this particular plant section, we have difficulties shutting down the plant, for instance, then they're already engaged within this pipeline of, let's say, exploring the data. And that's the first step in developing models eventually, right? Within the same tool where we allow them to explore the data, also give them the possibility to, in a self-service kind of way, at an abstracted level, train models.
Okay, so it's an auto ML tool, or what is it?
Yes, exactly. But at the same time, abstracting away all the details of the hyperparameters and so on, because the idea is really to engage them. And I would just like to conclude this by going back to what we were saying earlier, right? So I think, in my opinion, the success of industrial AI is based on engaging and including the domain experts into the loop, basically, right? And this is one of the ways we can do that.
John, at the end, what are the next steps for the augmented operator?
I mean, what we've done with the prototype so far is just implement it in a real facility on real data to try and understand what it's good for, how we can improve it, where it needs to be turned into a product. And that's really Benedict's activities during the next period. What we need to do is we need to extend it to other operators. We need to build confidence with our customers that this really is a tool and an assistance that they can benefit from. We need to build that experience.
This confidence depends on the process, that the process is stable, or that they reduce costs, or that they increase efficiency. What are the pain points of your customers?
I think it's like the new features that you and I experience in when we buy a new car. I mean, today you have advanced, you have lane keeping, you have advanced cruise control. You may have a car where the steering wheel starts to vibrate in your hands if you drift, and it can be quite disconcerting as the driver when you've not had that or experienced that before. But you very quickly become used to it. You hand over more and more trust to the system. I mean, it's the same in the same when you and I fly around Europe. I mean, essentially, from a technical perspective, we could take off, level flight, and land entirely without pilot in the cockpit. But would you and I do that? I'm not sure we would. So there is a process, there is time that is required for the current operators, to build up the confidence that the assistance that this augmented operator offers is helping them, is assisting them, is giving them good options and good advice, and it turns out to be useful. So on the one side, we've got the technology that needs to be refined, and we need to continue to provide more and more functions. But it's also very important that the operators and the operating companies understand that this is a valuable asset to them, and that when they then move from perhaps fully attended offshore facilities, that they can pull back operator staff to a central offshore facility, or even back to onshore, and can control these facilities remotely, that the operators and the companies are feeling confident that they have got the support that they need. So it's as much a technology development as it is workflows, the company philosophy on operating a facility, the regulatory control, and the local governments and standards that they are supporting this development.
So everything depends on Benedict, how he builds the product, right, Benedict?
At least that is an important piece of the story. But as John mentioned, there's a variety of things around this, and it's really the mix which hopefully helps this, changing the way how plant operation is and making some things better.
Thank you very much, guys. It was a pleasure to talk to you. Greetings to John to Oslo.
Thank you. Thank you very much, Robert.
Greetings to Adam.
Thank you, Robert.
And greetings to Benedict. It was a pleasure.
Thanks a lot, Robert.